This video is for Advanced Math, Unit 8, Lesson number 5, and we're going to venture into our trigonometric identities with this one here. Now, let's go ahead and take a step back to geometry, and we know that two positive angles are complementary. We know that complementary angles have a sum of 90 degrees. And now that we are in trigonometry, we take a little bit of step beyond that geometry and say 90 degrees is also pi over 2. Now let's look at this triangle, this right triangle we have here at figure 5.27. We know from our trigonometric ratios and their relationships that the sine of this angle theta is equal to opposite over hypotenuse. All right, from our SOHCAHTOA. And we can see that over here we have A over C. And remember, the way we have established this triangle is to say that our hypotenuse is C and our two legs are A and B. So because we have designated that, then the sine of that angle theta is the opposite A over the hypotenuse C. Well, because we have a right triangle and these two angles are complementary, since we have that angle theta, our other angle has to be 90 minus theta because those two angles have to add up to 90 degrees. Well, because of that, then we have the cosine of this angle here is equal to the ratio of the adjacent over the hypotenuse. Well, as we can see there, the adjacent angle for that 90 minus, or the adjacent side for 90 minus theta, is A. So what we had for the sine of theta, A over C, or the opposite over the hypotenuse, is equal to the cosine of the other angle, 90 degrees minus theta, which is because that is also the adjacent now is A over the hypotenuse C. So what we have here are what we call cofunctions. And we have a little bit of an extended definition there where f of theta equals g 90 degrees minus theta, where f and g are both trigonometric functions, and we also have g of theta equals f of 90 degrees minus theta. So we can carry these relationships out. We could show them on a triangle if we were to draw triangles for each one of these. But what we want to keep in mind are these cofunction identities. Now we're going to be looking at a couple other identities, so we got to keep them separated in our mind. So we have with our cofunctions, now we're looking at sine theta equals cosine 90 degrees minus theta, and we can see there we can replace 90 degrees with our pi over 2, our cofunction identities. So let's go ahead and look at a few of these right here. So we want a cofunction with the same value as sine 27 degrees. Well, sine and cosine are cofunctions, so sine of 27 is going to be equal to cosine of 90 degrees minus 27 degrees, which is going to be cosine 63 degrees. Simple enough. Now we can verify this with our magic math machines, and what we want to do here is first of all let's make sure we are in degree mode. All right, so now we are in degree mode, and we want to look at what is sine of 27 degrees, and we see the result there. Now let's look at the cosine of 63 degrees. Same thing, cofunction identities. So now that we have established that and shown it in our calculators, let's see here. Now let's look at cosine of 46 degrees. So its cofunction identity is going to be equal to sine of 90 degrees minus 46 degrees, which is the sine of 44. So cosine of 46 degrees has the same value as the sine of 44 degrees. Now let's look at our cosecant. We have cosecant and secant are cofunctions. So cosecant of pi over 3 is going to be equal to secant, and now that we're in radians, pi over 2 minus pi over 3. So secant of pi over 2 minus pi over 3 is equal to negative pi over 1, right? Of course not. We need to have equivalent fractions with the same denominator, and that is going to be equal to secant of pi over 6. Hey, how'd he do that? All right, let's take it back. Okay, go with this. Now, understand that we're just dealing with fractions here. We can look and say that if we have the fraction 1/2 minus 1/3, 1/2 minus 1/3, we need to have the same denominator. So we can put that as, let me see, 3 over 6 minus 2 over 6, and that equals 1 over 6. Well, what if, just what if, we were to throw in a pi there? Not the delicious kind of pi, but to say 1 pi over 2 minus 1 pi over 3. Well, that is equal to 3 pi over 6 minus 2 pi over 6, which equals 1 pi over 6. So just, we're throwing in these pi's in the numerator, but that does not change the basic fundamental principles of subtracting, adding and subtracting fractions. All right. Complexity does not change the rules of what we learned earlier in our mathematical lives. All right, so knowing that secant and cosecant are cofunctions, now we have secant of pi over 4, and we want to find a cofunction with the same value. So now we're looking at cosecant pi over 2 minus pi over 4, and that is cosecant pi over 4. And again, using the same principles of subtracting fractions that we showed on the one above. Okay, cotangent. We know cotangent and tangent. So cotangent of pi over 12 is equal to tangent pi over 2 minus pi over 12, which is tangent of 5 pi over 12. All right, lastly, we've got tangent pi over 6. As we can see there, we know that it's going to have a cofunction with cotangent, so we're looking at cotangent pi over 2 minus pi over 6. And now we're looking at cotangent of pi over 3. Wait a minute, how did I go from pi over 2, pi over 6 to pi over 3? Hey, I'll let you figure that one out on your own time. Okay, and there we have it with our cofunction identities. Next up, we are going to look at reciprocal identities with our trig functions. Now, just from SOHCAHTOA, you should have been able to figure out these reciprocal identities, but now let's show it specifically and explicitly. So if we have a right triangle, all right, we have a right triangle with sides A and B, hypotenuse C. And now let's look at sine theta. We know sine of theta is equal to A over C. And cosine theta, not cosine, cosecant theta That is equal to hypotenuse over opposite. So that is equal to C over A. Well, what happens if we say, if we look at the reciprocal of A over C? So 1 over A over C is equal to 1 over 1 times C over A. C over A. Let's make that A look a little better there. All right, that is equal to 1 over 1 times C over A. All right, we cannot forget, if we're dividing by a fraction, that's the same thing as multiplying by the reciprocal. And that is equal to 1 over 1 times C over A is equal to C over A. Well, would you look at that? C over A is our cosecant. So that is how we get our reciprocal identity, where sine theta equals 1 over cosecant theta, and cosecant theta equals 1 over sine theta. And we could go through and show the same thing for cosine and secant, tangent and cotangent. But I don't think it's necessary to show the proof for all of them there. But now we have our reciprocal identities, which again, we can try to memorize all of our reciprocal identities, or we can just go back to our triangle, oriented the way we have it here, and understanding that sine theta is opposite over hypotenuse. Cosecant is hypotenuse over opposite. Those are reciprocals. Okay, so we want to look at these examples here using our reciprocal identities to find our other trigonometric functions. We have sine theta equals 2/5 cosine theta equals square root 21 over 5. Now, we know that tangent theta is equal to, as we see there, sine theta over cosine theta. Let me see. I don't have a lot of room. I want to show that. All right, we'll do it up here. And I'm going to be using the same triangle we have down there. All right, using that triangle, we know that, a little bit more room there. We know that sine theta opposite over hypotenuse, and cosine theta is adjacent over hypotenuse. And we know that tangent theta is opposite over adjacent. So what will happen if we do sine theta over cosine theta? Sine theta divided by cosine theta. Well, that gives us A over C divided by B over C, which is equal to A over C times C over B. Once again, we're dividing by a fraction, so that's the same thing as multiplying by the reciprocal. And that equals A over B, which is opposite over adjacent. So that is how we get that tangent theta is equal to sine theta divided by cosine theta. All right, so back to where we left off. Tangent theta equals sine theta over cosine theta. So now we have tangent theta is equal to 2/5 divided by square root 21/5, which is equal to 2/5 times 5 over square root 21. Those 5s divide themselves out, and we have tangent theta is equal to 2 over square root of 21. which we cannot have, or we can have it, we just cannot leave it in that form. So that is equal to 2 square root 21 over 21. There's our tangent theta. And now for the other three, we know that cosecant theta is the reciprocal or the inverse of sine theta, so that is equal to 5/2. Secant theta, reciprocal of our cosine, so that is equal to 5 over square root 21, which is equal to 5 square root 21 over 21. And last but not least, our cotangent theta, that is equal to, and now we want to use this one right here for our cotangent, square root 21 over 2. All right. Easy as falling off a bicycle, right? It's really not that difficult once you do a few of these and really get used to doing trigonometry. All right, so let's look at this next one here. We have a sine of 2/3, cosine of square root 5 over 3, square root 5/3. So let's go ahead. Same thing. We know tangent. Tangent theta is going to be, and there is a shortcut, but I don't want to show that shortcut right now because I want us to get used to the math and understanding the math behind this, the full math behind this. So that's 2/3 divided by square root 5/3, which is 2/3 times 3 over square root 5. 2 over square root 5, which is 2 square root 5 divided by 5. There's our tangent theta. Cosecant theta is going to be 3/2. Secant theta is going to be 3 divided by the square root 5, which is 3 square root 5 divided by 5. And cotangent theta, last but not least, is going to be square root 5 divided by 2. Now, one last thing I want us to look at, we have cotangent is equal to 1 over the tangent. Tangent and cotangent are reciprocals, but also we can look at the fact that if we do, all right, so we have cosine theta square root 5 over 3, square root 5 divided by 3. Sine theta equals 2/3. Now let's just say, well, what if we just want to do cosine divided by sine? Now we're going to have square root 5 divided by 3 divided by 2/3, which is equal to square root 5/3 times 3/2, which equals square root 5 divided by 2, which is our cotangent. So we have those two identities we can use for cotangent, where cotangent is 1 over tangent, which is the same thing as cosine over sine. We really didn't have to go through all of that math because of the fact that since tangent is sine over cosine and cotangent is 1 over tangent, we just take the reciprocal of tangent, which is cosine over sine, and we have cotangent is equal to cosine over sine. Maybe that was a little bit of a tongue twister, but just wanted to point that out. All right, next, let's look at this triangle that we have here. right triangle, and we know our Pythagorean theorem, our Pythagorean formula. And let's follow what it says here. We're going to take that Pythagorean formula, a squared plus b squared equals c squared, and we want to divide everything by c squared. And that gives us a squared divided by c squared plus b squared divided by c squared equals 1. Now let's go back to our trigonometric functions. We know that with this setup, with this orientation, sine theta equals a over c, a divided by c, and cosine theta is equal to b divided by c. Now if we substitute these right here, or if we square them, let's show, that means sine squared theta equals a squared over c squared. And the same holds true for cosine. So what that gives us is sine squared theta plus cosine squared theta equals 1. And that is, as we can see there, our Pythagorean identity. Now let's take it a little further. With that, we have sine squared theta plus cosine squared theta equals 1. And if we divide everything by sine squared theta, what that gives us, sine squared theta divided by sine squared theta is equal to 1. Cosine divided by sine is our cotangent, so cosine squared divided by sine squared is cotangent squared theta. And 1 divided by sine is cosecant, so 1 divided by sine squared is cosecant squared theta. Now let's do the same thing dividing by cosine squared. So we have sine squared theta plus cosine squared theta equals 1, and dividing everything by cosine squared theta. Sine divided by cosine is tangent, so sine squared divided by cosine squared, tangent squared theta. Cosine squared theta divided by cosine squared theta is equal to 1. 1 divided by cosine is secant, so 1 divided by cosine squared is secant squared theta. Now, as you see there, these are the 3 Pythagorean identities. Now, you can memorize all 3 of these, or really all you need to do is memorize the first one, sine squared plus cosine squared equals 1. That's the only one you need to remember. I distinctly remember my calculus professor in college telling us, hey, you only need to memorize 1. You don't have to memorize a whole lot of stuff in math. You can memorize just a few things and then be able to mathematically derive or arrive at other principles that you need to get. So if you just memorize sine squared theta plus cosine squared theta equals 1, then you can use the division that we showed to derive the other 2 Pythagorean identities, so you don't have to memorize all 3 of those identities. Okay, so let's put this into action. Looking at these 2 examples, we know that sine theta is 3/5 and theta is an acute angle, and we want to use identities to find the value of cosine theta. Well, we want to use the fact that sine squared theta plus cosine squared theta equals 1, which means 3/5 squared plus cosine squared theta equals 1, which means 9/25 plus cosine squared theta equals 1. And now going through this, I'm not going to show all of the math. All right, something you should know how to do by now. Subtracting that 9/25 from both sides, we get cosine squared theta equals 16/25. Now, if we take the square root of both sides, we know that cosine theta equals 4/5. There we go. Next one, we've got tangent theta equals square root 3/3, and we want to find the value of secant theta. So we have our identity, tangent squared theta plus 1 equals secant squared theta. So square root 3 divided by 3 squared plus 1 equals secant squared theta. 3/9 plus 1 equals secant squared theta. So we have 12/9 equals secant squared theta. And now that we know secant squared, we take the square root of both sides, and that gives us secant theta equals square root 12 divided by 3. We can simplify that radical and get that secant theta equals 2 square root 3 divided by 3. So we have cofunction identities, reciprocal identities, and now our Pythagorean identities that we've got to keep them all straight in our head. And that is it for this video.